But let me say that here's another unit of measurement, rotation. Let's write down the conversion, right? One rotation equals what? 360 degrees. Okay? Or I could say 1 degree equals what? Ooh, that's not so nice. 180 degrees, you guys told me, was how many rotations? Half of a rotation. So I guess 1 degree, I could do my algebra, it's going to be 360th of a rotation, right? People are very comfortable with rotations being angles. All right, so when we rotate, you do understand I can do two different tricks. I can do that 180, but I can also do that 180. Are those the same? Those are different angles. We have to call one of them positive and one of them negative, okay? And so what we're going to do when we talk about rotations, when we talk about angles, is we're going to go to our XY plane, okay? And we're going to draw along the x-axis what is called the initial side of an angle. That's the initial side of an angle. And when we rotate, well, I guess we could go clockwise or we could go counterclockwise, right? You guys with me? And it makes sense, I guess, that we would go counterclockwise. Well, we do. We go counterclockwise is positive. Actually, if any of you're probably familiar with the quadrants. You'll notice that we're going to go counterclockwise. We go through the quadrants in order, 1, 2, 3, 4. Okay? So an angle has an initial side, and it also has a terminal side. It's where the rotation stops. By the way, how much of a rotation is that? Not very much. Right? Maybe it's 1/8 of an entire rotation, or something like that. Okay? Well, it turns out that the best way to measure angles is not degrees and it's not rotations, but it's this unit of measurement called radian. I'll give you the definition and then I'll talk about what we're going to do with radians. Okay? So the idea is a radian is the angle, and I'll say rotation so that you guys remind yourselves what an angle really is, such that the length of the arc on the unit circle, I don't even to say on the circle, is equal to the radius. And I have to draw a picture of this for you to see what I'm talking about. You'll notice that in the picture above, I started to draw a circle because circular motion is rotation. And the blue arc was right here. Well, if I rotate enough, so here's my initial side again. If I rotate enough, I can get to the point where the length of that curve would be exactly the same as the length of the radius. You guys with me on that? See here, in this picture, I claim that R is bigger than what I might call S, the length of the arc. R is bigger than S. But if I rotate a little bit more, I can make it so that R equals S. Are you with me? If I rotate too far, then what happens? S is bigger, right? Well, it turns out that that's a really nice angle to use as our unit of measurement. And I think we'll see why in a minute here. But it's something like that. That's about 1 radian, that angle. Now, the funny thing is, students often ask me, well, how many degrees is that? And I don't know. It's not something I have memorized, because we don't do it that way. But what we do is we go back to our idea of rotations. Let's do some conversions. So, if I have 1 rotation, you guys told me that that's the same as 360 degrees. Right? And I could draw a picture of that. So this is an interesting picture now that we have what we call an initial side and a terminal side. Here's the initial side. But where's the terminal side? Same place. You can do that. I told you I can do that. You guys didn't believe me. All right. I know, that was a negative. Anyways, that's the initial side and the terminal side are the same, but it's an angle, right? So this is 1 rotation. It's 360 degrees. I showed you negative 360. How many radians is that? Well, what we do is we measure the length of the green arc. How do you find the length of that arc? Well, it's a complete circle. So you know what I'm really finding? There's a word. What's the word? There it is. Put it back on the page. Circumference. We have a formula for that. Pi, oh, that's area, pi r squared. The squared is when you get area. What is it? 2 pi r is one way to say it, or pi times diameter I've also heard. It's 2 pi times the radius. Are you with me? But wait a minute. What you want is you want the radius. Instead, what we do is we say that this angle is 2 pi radians. Because however big that radius is, you call that basically the unit of measurement. That's 1 radian. So 1 rotation is equal to 2 pi radians. And see, now I can do some other conversions. I can say, okay, suppose I have 180 degrees. We know that's half of a rotation. How many radians is it? Do you see that it would have to be pi? Sure. Pi radians. And so there's a picture that comes now, which is we draw the x and y plane, and we say that we always have the initial side here, and then we're rotating in that direction, right? And let's suppose I end up over here. Well, yeah, that would be pi radians. And this is really the key fact that I remember. 180 degrees is equal to pi radians. And by the way, in mathematics, we use radians so often as the standard measure of angles. We don't even write units normally. You'll just see that 180 degrees is equal to pi, and they won't even write radians.